welcome to another video on math. Your favorite, right? This video is finding inverses involving radical functions, which in turn involves quadratic. Because if you find the inverse of a quadratic function, it's a radical function, meaning it's got that square root symbol in it. So the inverse of a radical function is a quadratic. So let's say they say find the inverse of the square root of 2x minus 7. And they may give you something about the domain, in that we know that you can't have a negative under the radical. It has to be greater than or equal to 0. And if I solve that, so they might say something like this. And that's just that x greater than or equal to 7/2 is just saying that that's the domain for this radical function. So the process of finding the inverse is the same. We replace the f of x with a y, and then the x and the y need to switch places. And then you're solving for y. So you want to isolate the part that's got the radical before you start undoing the radical. And in our situation, the radical is already isolated. So in order to undo the radical and get our variable out from under that radical, because it's a square root, we can square it. Now with square roots, there is an invisible 2 in sort of that V spot. And this is called the index. And they just choose not to write it for the square root, but you could have it like this would be the cube root, this would be the fourth root. And what's important as far as knowing the index is if I want to undo a radical, I have to have an exponent that matches this index. If those match, they undo each other, and you're left with just what's under the radical. So we've got this invisible 2 there, so my exponent and my index match. So now I'm left with, oops, and I got to square the other side. Forgot about that. What you do to one side, you have to do to the other side. So I have x squared is equal to 2y minus 7. And I'm solving for y, so I'm going to add 7 to both sides and divide by 2. And so I get, and I can split this up over that variable, or over that common denominator. But then they're going to ask for a domain for this. You're like, what do they mean, domain? Well, remember, when you find the domain for a quadratic, which when you graph it as a parabola, you have to cut it in half. And so you find the inverse for 1/2 or the other half. So what they're saying, if they're asking about the domain for your inverse, they're asking you for which half of this quadratic, this parabola, are you talking about? Again, you have to think about finding the inverse of the quadratic. And that was in a previous video. And when you find the inverse, remember there's always that plus or minus in front of the radical. And if you have the plus in front of the radical, that means the right half of the parabola. If you have the minus, that means the left half of the parabola. So we have to go back and look and see in our original radical up here what sign is in front of it. Well, if there's no sign in front of it, that means it's positive. So this particular function, we are talking about the right half of our parabola. So they'll want to know what is the domain for the right half of that parabola. Well, we can go ahead and graph our function onto Desmos. So let's go ahead and do that. Let's see, x squared divided by 2, I believe, plus 7 divided by 2. All right, so here is our parabola, and here is our vertex. Oops, let me go back. And the x-coordinate of our vertex is 0. Now I'm ready for the screenshot. So that means the right half of the parabola, we're talking about 0 to infinity. So this would be the domain they would be asking for. So we started off with this function. They asked us to find the inverse, which we did. And then they asked for the domain for our inverse. And we're talking about the right half of the parabola because there's a positive or invisible positive sign in front of our radical, which means the right half of the parabola. So we took our quadratic, we graphed it on Desmos. We saw our vertex has an x-coordinate of 0. Therefore, the right half of the parabola goes from 0 to infinity. So that's an example of finding the inverse of a radical, a square root function.